Who can agree with me that every engineering team has this one system that everyone depends on it, but no one's really want to touch? So at the data engineering, that system was our A/B testing pipeline. And today, I want to share with you how we converted that pain to something that actually works much better and gives tremendous value for all the product teams at Wix. Before that, I'm Arik. I'm nearly 8 years at Wix. I'm leading the Data Tools Automation Group at the Data Infra. I'm father of 2 wonderful kids. I'm married to 1 lady, and I report to all of them, as all fathers do. But before we talk about pain and gain, let me briefly explain what is A/B testing and why it's even matter. So A/B testing is exposing different versions of features to real users and measure the impact of the change. First, we take our users and randomly split them into 2 groups. One half labeled as version A and the other half labeled as version B. The feature can be 2 different buttons, page layout, recommendation. It does not really matter. It can be any user-facing change of a feature. Next, we make sure the users really exposed to the change. In this case, it means the user really saw the buttons that we are testing. Then we track what they do, the KPI itself. For example, in group A, 20% of the users click on the button, and in group B, 40% of them click on the button. So B is better than A, right? Who thinks that B is better than A? And who think we cannot claim it yet? Right. So in reality, we don't just trust the raw number. We have to prove the difference statistically because it can be just noise or random luck. Only then we can declare with confidence that B is truly beats A and it's safe to roll it out. Also important to mention that the experiment include multiple KPIs, and in fact some of them include hundreds of KPIs, but the main KPIs that appear in almost all the experiments is obviously the premium purchase. So what is Wixer? Wixer is the data collection and statistical analysis for all the defined A/B tests in Wix. It's an internal tool that helps analysts and product managers to understand the experiment performance while also serving as a primary tool for deciding whether a new feature should be released or not. Now, imagine if every product team at Wix had to build its own experiment data pipeline. It's an extremely time-consuming and nearly impossible for all our business analysts and data engineers to build and maintain all these KPIs along with backfill capabilities for all the A/B tests in every single day. And this is the real power of Wixer. Behind the scene, it manages the most heavy and complex pipeline, support hundreds of KPI per experiment, and substantially increase the dev velocity across the entire data organization. And believe it or not, even AI can't replace it. Or at least not yet. But I'm just kidding. You are about to see how we significantly adopted AI in the process, but you will need to wait until the end. So let's talk a bit about volumes and numbers. In a single day, Wixer collects the data for more than 100 experiments in average and 10,000 KPIs by scanning half terabyte of raw data, which producing 150 million events. So now let me touch on the architecture in a nutshell. Under the hood, it built on Airflow powered by Spark. Airflow is the tool for task scheduling, and Spark is a distributed engine for scalable data processing. So how does it work? First, we collect event data. When user participate in experiment, we capture the exposure and label event and distinguish who saw which variant. We also collect the KPI event, which, as we mentioned, the metrics we are measuring. Second, we aggregate. Spark join exposure with user data, filter out the bots, and compute aggregation by different breakdowns. Third, statistical analysis. We calculated p-value, confidence interval, and effect size to show if the results are statistically significant. Finally, all the results are stored in S3 using iceberg format, which is a table format designed for analytics in data lake. The results are also available in Tableau, providing convenient visibility across all experiments in one place. And on top of the final result, we added an AI skill that analyze experiment result and provide insights and recommendation to our users. And all these pipelines run on a daily basis for all active experiments in parallel. So now, after we understand what is A/B testing and what is Wixer, let me tell you the story of Wixer from pain to gain. So after a long period of incremental development in Wixer, the process has never undergone a full re-architecture. And while our technology in the data engineering evolved over the time, so Wixer was not fully utilizing with the latest capabilities of these technologies. Also, the product ownership has changed over the time and moved between teams. It started in the core team long time ago, and then it moved to the analyst guild, and then it got back to the core team. So many hands were involved in the code along the years. And the intent to increase the coverage for more experiments to be covered by Wixer sometimes took the priority over the need to invest the system stability, and definitely not for a full rewrite like we had last year. From the technical perspective, and I think that this is the core of the pain point, the main problem with the old architecture is that it was one huge sequential monolithic process. We collected all the labels, exposures, breakdowns, and KPI for all the experiments together. So each time we had an incident in one of these data entities, it created a big chaos and impact all the other experiments. Now imagine how much it complicated to do a troubleshooting for such an intertwined process. Also, the Wixer tables were updated by multiple processes. We had the main process that ran in the morning and collect the data of yesterday, and we had the backfill process that ran at noon and collect the data that was not refreshed in the morning, and also all the data for the KPIs that were changed yesterday. So pretty complicated. All of that instead of having one robust process that handle everything. So it's not an ideal design and definitely increase our complexity. Also, this design forced us to be constantly up to date. And if we were not up to date, we could have data corruption. And if we have data corruption, we needed to do recovery. And recovery in this kind of system is time consuming. And a few times it's even took for us several days to recover the data. And while we recover the data, so A/B test ran blindly. And this was very painful. Now let's talk about how the user flow impact the system volumes. So invalid KPIs were skipped rather than fixed. So basically we kept maintaining garbage of KPI, and there was no limitation on the numbers of the KPIs that were added to the test. So the system was constantly overloaded with KPIs that were not even needed. So unfortunately, this was how the Wixer discussion channel looked like almost on a weekly basis. Pretty chaotic. And we reached to a point that we understand that the process is unmaintainable anymore and we must switch the disk. And in the bottom line, when the process is unmaintainable, so also our users are getting a really bad service. And this is something we wanted to change. So before diving deep into the rewrite, we asked our users what they really think about Wixer. And the main conclusions were that first, Wixer is good, but it should be much more resilient and robust. And on the other hand, they were very satisfied from the fact that it handles their statistical analysis. So we thought to ourselves, what will make an amazing A/B testing tool analysis? And we came up with 6 key pillars that we believe are essential for the new platform. So it needs to be easy to use. It needs to be reliable. Obviously, after the long prologue we had on the maintenance, so it must be robust. We need to have high coverage, means that we need to catch many data cases as we can. It needs to be flexible and also transparent, means that the users will be able to see the experiment status in every single point along the day. So let's break it one by one and see how we covered all of them. So we already knew that the whole system was easy to use because it was pretty convenient to configure an experiment and analyze the result the day after, exactly as our users voted in the survey I mentioned earlier. In addition, as long as the data was refreshed, so users felt confident with the result, which is great. And this is something we definitely wanted to preserve. But we still had 4 other pillars. And the brilliant idea behind the new architecture is simple. Instead of having one massive pipeline processing everything together, now each experiment is handled by a separate pipeline. And I guess you're all familiar with the well-known engineering concept, breaking the monolith into microservices. Now, once we have error, and definitely we expect to have error from time to time in such a huge and complex system, So the impact is limited only for the experiments that include the problematic data entity. So essentially, we lower the chances of having cross effect by a large percentage. It's an incremental process that's sophisticated enough to catch up even if a KPI, exposure, or breakdown was broken for a period of time. And in addition, the process aimed to be much more modular, and adding more features was expected to be easier than the previous design. And in retrospective, it proved itself, as I will elaborate later on. So getting back to the pillar list, seems like we can mark down also robust and high coverage. But so far we mentioned how the maintenance of the process improved, but how actually the users directly benefit from the new design. Just a second. So before the rewrite, any change to a KPI required a separate backfill process across all experiments. However, this process was limited to the first 7 days of the experiment start date. After that, backfill were not triggered. So as part of the new design, we took the opportunity to address the top feature request. Now data entities backfill is built in directly into the experiment calculation, without the need of a separate process. This means backfill can be performed at any time during the lifetime of the experiment. So getting rid of this limitation was a huge relief for our business analyst. So we can mark down also the flexible pillar, right? Cool. Moreover, since we eliminated the backfill process, now the experiment calculation is now depend for all the KPIs to be ready. And once analysts configure only the relevant KPI and ensure that its sources are up to date early, so also the experiment results are aimed to be published early. And by this design, we increase the incentive of the KPI owner to make sure that it's we increase the incentive of the KPI owner to make sure that their KPI are updated on time, and it's also aligned with the data freshness goal of the guild. We also added alerting mechanism that will update the users for any informative status of the experiment. For instance, if an experiment data is ready, if one of the data entities is not valid and why it's not valid, and so on. And that is obviously to minimize our interaction in the Slack channel and to make our system much more less pillar, transparent, exactly. So, but we're all mature people and we understand that there is no such a thing free lunch. And in engineering language, we like to call it trade-off. We understand that in order to have a lightweight system, we need to change a little bit the user flow. So we added 2 small limitations. Now analysts can set up to 500 KPIs in each experiment, and the experiment lifetime was limited to 42 days max. And we understand that this might impact the flexibility a bit, and we did it not because we could not handle it from the engineering perspective, but only because it's aligned with the basic guidelines of A/B testing and create much better and efficient user flow. So remember the high coverage pillar we mentioned earlier? So here is a great example of it in action. The new architecture opened the door to the modern AI-driven product. We implemented a new type of KPI that evaluated user conversation and AI interaction, something that was definitely not possible in the old system. Along with measuring clicks as regular KPI, we now evaluated complex interaction using LLM as a judge, where prompt score the quality of the AI output. And it does not just tell us which variant won, it shows exactly how the AI improved. So how does it work? The KPI works by sending each user conversation to an LLM, which scores it based on a prompt we define. For example, how positive or frustrated did the user sound by the end of the conversation? That score becomes the metric we compare across experiment variant, and for each metric we match the most relevant statistical test. So for the first time, we can run an A/B test and see not just who clicked more, but whose AI responses were actually better. So let's do a short recap for all of you that were a bit zoned out. We had a system that none of the developers wanted to touch, and it worked, but sometimes, not always. We broke the monolith, and now each experiment is running on an isolated pipeline, but on the same generic code. We covered all the 6 pillars that we set to ourselves, and we're very happy about that. Another thing that we're pretty satisfied is that the Wixer discussion channel is now much more quiet, and it makes us to be available for other challenges projects. Also, we now evaluated AI with AI by using LLM as a judge. So in the bottom line, the new modular design of Wixer allowed us to quickly adapt to the rapid changes in the industry, and it came at exactly the right time. Thank you very much. I hope you had a great time.